scenario involves multiple 400 amp service disconnects located in close proximity. A supplemental grounding electrode is driven according to section 250.53e of the National Electrical Code, NEC. A number 6 grounding electrode conductor is run from service disconnect number 1. Individual number 6 conductors are run from service disconnects number 2, 3, and 4, and tap to the grounding electrode conductor from service disconnect number 1. According to the NEC, this installation is not code compliant. Here's a breakdown of why this installation method is not compliant with the NEC and the correct approach for grounding multiple service disconnects. Firstly, each service disconnect must have its own grounding electrode conductor run to the grounding electrode system. Tapping into a single grounding electrode conductor from one service disconnect to serve others is not permitted. The NEC requires a direct connection from each service disconnect to the grounding electrode. Secondly, the size of the grounding electrode conductor is determined by the size of the service entrance conductors. Table 250.66 in the NEC dictates the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. Since the service disconnects are 400 amps each, the service entrance conductors are likely sized to carry that current. Therefore, the grounding electrode conductor must be sized accordingly, and a number 6 conductor may not be sufficient depending on the service entrance conductor size. Thirdly, section 250.24a of the NEC requires that the grounding electrode conductor be connected to the grounded conductor at each service disconnect. This ensures that each service has a direct path to ground, which is essential for safety and proper operation of overcurrent protective devices. Fourthly, the grounding electrode system must consist of one or more of the electrodes specified in section 250.52 of the NEC. These electrodes can include a metal underground water pipe, a metal frame of the building or structure, a concrete encased electrode, or a ground ring. Supplemental electrodes, such as ground rods or ground plates, are often required to improve the effectiveness of the grounding system. Fifthly, when multiple service disconnects are installed in a single building, they must be grounded to the same grounding electrode system. This ensures that all services are at the same ground potential, which minimizes the risk of voltage differences and potential hazards. Sixthly, the grounding electrode conductor must be continuous and unbroken except for connections made at splices or terminations. Splices and terminations must be made using approved methods such as reversible compression connectors or exothermic welding. Seventhly, the grounding electrode conductor must be securely connected to the grounding electrode using approved methods such as grounding clamps or lugs. The connection must be accessible for inspection and maintenance. Eighthly, the grounding electrode conductor must be protected from physical damage by being installed in conduit or other suitable enclosures where it is exposed to mechanical stress. Ninthly, the path to ground from circuits, equipment, and metal enclosures must be permanent and continuous and have ample carrying capacity to conduct safely any fault current likely to be imposed on it. Tenthly, the impedance of the grounding path must be sufficiently low to limit the voltage to ground and to facilitate the operation of overcurrent protective devices in the circuit. To correct the non-compliant installation, you must run a separate grounding electrode conductor from each of the service disconnects number 2, 3, and 4 to the grounding electrode system. The size of each grounding electrode conductor must be determined based on the size of the service entrance conductors for each disconnect, in accordance with Table 250.66 of the NEC. All connections must be made using approved methods, and the grounding electrode conductors must be protected from physical damage. In summary, tapping a single grounding electrode conductor from one service disconnect to serve multiple service disconnects is a violation of the NEC. Each service disconnect must have its own grounding electrode conductor run to the grounding electrode system size according to the service entrance conductors. This ensures the safe and effective grounding system, which is essential for protecting people and property from electrical hazards. Always consult the latest edition of the NEC and local electrical codes for specific requirements and guidance. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. They will ensure that the installation is safe and compliant with all applicable codes. Proper grounding is a critical aspect of electrical safety, and it should never be overlooked. Non-compliant grounding can lead to electrical shock, fire hazards, and equipment damage. Therefore, it is essential to understand and follow the NEC requirements for grounding electrical systems. The code provides specific guidelines for grounding different types of electrical equipment, including service disconnects, distribution panels, and branch circuits. By following these guidelines, you can ensure that your electrical system is properly grounded and safe to operate. If you have any questions or concerns about grounding, consult with a qualified electrician or electrical inspector. They can provide you with expert advice and guidance on grounding requirements and best practices. Remember, safety should always be your top priority when working with electricity.